We're going to go ahead and apply those basic probability rules. So let's take a look at an example. Distance learning courses are rapidly gaining popularity. So we're going to randomly select an undergraduate student who's taken a distance learning course for credit and record the student's age. And here is our results from it. The first thing tells us show that this is a legitimate probability model. Well, a legitimate probability model always adds up to 1 because this is our sample space. And from the previous page we said our sample space, the probability is always 1. So 0.57 and it indeed does equal 1. Therefore it is a legitimate probability model. The second question says the probability that a chosen student is not in the traditional age 18 to 23. So what they're asking for is probability not 18 to 23. That is the same thing as the probability of the complement, which is 1 minus the probability of 18 to 23. So you could do this one of two ways. You could actually say, okay, well 1 minus 0.57 gives me 0.43. Or, I guess a little bit of a longer way is, well, you could just add up the probability of 24 through 29 plus 30 through 39 and 40 and older. And that would be 0.17 plus 0.14 plus 0.12, and sure enough that gives you 0.43. Both of those ways do work. It is whatever and however you feel most comfortable with. Students in a college stats class want to find out how common it is for young adults to have their ears pierced. They record data on two variables, gender and whether or not the student has pierced ears. There was a total of 178 people, and here's the two-way table. So we know that we want the probability of they have pierced ears. There is a total of 178 people. I get that from there, and I see that pierced ears, I have 103 say yes and 75 say no, but I'm just interested in this 103 because I do want pierced ears. So my probability is 103 over 178. The next one asks for the is male and has pierced ears. So pierced ears we're looking for yes, and males we're looking for yes. So we're looking at this intersection because we want to see where the male has pierced ears, and that is a total of 19. 19 males and pierced ears. And there's a total of 178, so the answer would be 19 over 178. The next one asks for is male or has pierced ears. So if we just look at male, there's a total of 90 males And if we look at pierced ears, there is a total for yes to pierced ears is a total of 103. But look at what happens when we try to add those together. Sorry, that's supposed to say 178. You get 193 over 178. Well, you can't do this. Why can't we do this? Is these events are not mutually exclusive. Meaning there's overlap. There's overlap. So what happened is we double counted. And the reason is if 103 have pierced ears, 19 are males. And so what happens is this intersection point right there, circled in the blue, because I was curious about pierced ears and males, it essentially got double counted. So the better way to go ahead and look at this is, since we can't double count, is we essentially want these three columns that, or sorry, these three boxes where we got 19 males that say yes. There's 71 males that are no, and then there's 84 females that say yes. Because we have to have pierced ears here, so we are just concerned with the yes and we're just concerned with the male column. We just can't double count. So the probability of this is 19 plus 71 plus 84, and that gives you 174, and there's a total of 178. And this makes sense because male or pierced ear, there's only 4 females who do not have pierced ears.